Hello everyone, welcome to AGENTIC Crack from Scratch series. In this series, we'll build a production grade agentic RAG system step by step. This is episode 3. In this episode, we are going to discuss important concepts like tokens, prompts, context, and memory. Then we will add conversation ability, and lastly, we'll provide context to the application. Once again, welcome to Building SaaS channel, and let's get started. Let's start by understanding what actually happens when we call an LLM. First, we send a user prompt to the model, but the model doesn't read the text the way humans do. Before the LLM can process anything, your prompt is converted into tokens. So the real question is, what exactly is a token? A token is simply a chunk of text, and a chunk can be different things. It can be a full word, can be a part of a word, or even something small as a space. For example, the word building might be split into multiple tokens depending upon the tokenizer. These tokens that come from your prompt are called input tokens. Once the LLM receives these tokens, it processes them and generates tokens as output, which are then converted back into readable text. And this leads to something very important. LLM pricing is based on tokens. The total cost of an LLM call is calculated based on the number of input tokens and the number of output tokens generated by the model. So every prompt you send and every word the model generates contributes to the overall cost. Now let's talk another very important concept, context. An LLM does not know anything about you or your business by default. It does not know your company data, your documents, your users, or your internal systems. So if we want LLM to answer questions related to our application, we need to provide that information as context. This context can come from different places such as documents, databases, APIs, external systems, or even previous messages in conversation. When we send this additional information to LLM, we are injecting context into prompt. But remember something very important. Just like user prompt, context also gets converted into token, which means context increases the number of input tokens and therefore affects both cost and performance. Another key concept is the context window. Every large language model has a maximum number of tokens it can process at once. This limit includes user input, context data, system prompts, and the model's output. If we exceed this limit, the model cannot process the request. So when building real-world applications, managing context effectively becomes extremely important. Now that we understand tokens and context, let's look at something interesting. Let's test our application. If I say my name is Rob and then I ask what is my name, you'll notice something. The model doesn't remember the previous messages. Why? Because right now our application is sending each message as completely separate request to LLM. So the model has no memory of previous messages. To fix this, we need to send the entire conversation history to the model. Instead of sending just the latest user message, we'll send all the messages in the conversation, both from user and AI. For now, we'll implement a simple approach. We'll just send the entire message history every time. Let's start with Backend. First, we update our API to accept multiple messages from the client instead of single message. Then we create an helper function to convert the UI messages into LangChain message object. This mapping converts messages into appropriate LangChain classes like human message, AI message, and any other message type. After that, the invoke function inside our chat service will accept the list of messages and pass that directly to the model. Once that's done, our backend is ready. Now let's update the front end. Instead of sending just the latest message, we will send all the messages stored in the state variable. So every time the user sends a message, the request will contain the entire conversation history. Now let's test the application again. This time when we say my name is Rob and then ask what's my name, the model correctly responds with Rob, and that's because we are now sending the entire conversation history as a context, which means we have successfully enabled conversational memory in our application. Now let's move a step further. In this tutorial, we are building a chatbot for an automobile dealership. To simulate the real scenario, we have some example data. For instance, we have a customer named Rob who owns BMW X1. Rob's entire customer profile, including his vehicle details and other information, is stored in a file. We also have a PDF document that contains information about all the BMW vehicles available at the dealership, including specifications, pricing, and other details. Our goal is to allow chatbot to use this information when responding to users, and the first step towards doing that is adding system prompt. What is a system message? When we interact with an LLM, we usually send different types of messages. For example, user message, questions or prompts from user. AI messages, responses generated by the model. System messages, instructions that guide how the model should behave. A system message is essentially a set of instructions for LLM. Tells the model things like who it is supposed to be, what role it should play, how it should respond, what information it should prioritize. Think of a system message as setting the personality and rule for the AI before the conversation even begins. For example, in our case, we might instruct the model like this. You are a customer service assistant for a BMW dealership. Help customers with vehicle information, service requests, bookings, and queries. Use the provided documents and customer data when responding. These instructions ensure that the model behaves like a BMW dealership assistant instead of generic chatbot. This is where the prompt engineering comes in. Prompt engineering is a process of carefully designing the instructions and inputs we send to the model so that it produces better and more reliable outputs. Now let's look at a more practical scenario. Rob wants to know when car was last serviced, but if you try asking the chatbot right now, it won't be able to answer that question because the system doesn't have access to Rob's personal profile. So the first step is to create a structured user profile for Rob. This profile contains information such as customer name, vehicle owned, service history, purchase details, other relevant customer data. Once we have this information, we inject it into the system prompt as a part of context. Now the LLM has access to Rob's profile and can answer questions like when was my car last serviced. Next, Rob asks another question. He says, show me the cars that are around $50,000. This information isn't in Rob's profile. Instead, it exists inside PDF documents that contains the list of BMW vehicles. So what we do is parse that document and extract the information, and we construct the structured profile of available cars, including things like model name, price, specification, features. And just like Rob's profile, we inject the information into the system prompt as an additional context. At this point, our system can answer questions related to Rob's profile's BMW vehicle information from the document. In the world of AI application, this pattern is commonly known as context injection. We are injecting external knowledge into the prompt so that the LLM can use the information while generating the response. This is actually one of the core ideas behind retrieval augment generation, or RAG, which we will explore more deeply in later in the series. However, there is a major problem with the way we have implemented our system right now. Every single time a user sends a message, we rebuild the entire context that includes Rob's full customer profile, the entire BMW vehicle catalog, and the conversation history. Then we send all this information to LLM even if a user asks something very simple. For example, if user just say hi, we still construct the entire context and send it to the model. In our example, this might result around 2000 tokens being sent to the LLM just to respond to a simple greeting. This is clearly not an efficient approach. It increases cost, latency, token usage, and more importantly, it doesn't scale for real-world applications. Let's look at another scenario. Now, Rob wants to book a service appointment for his BMW X1. If he asks something like, can you book a service appointment for my car next week, our current system cannot actually perform that task because right now our application can only generate responses using context. It cannot perform real actions such as checking service availability, booking an appointment, updating the database, calling an external API. In other words, our system can talk about things but cannot actually do things. To solve these problems, we need two important capabilities. First, we will need a way for LLM to dynamically fetch information from external systems instead of injecting all the data into the prompt every time. Second, we need a way for LLM to perform actions like booking service appointments or retrieving data from database. This is where two powerful concepts come into picture: tools and agents. So in the next episode, we are going to start building our first AI tool. We'll give our AI assistant the ability to fetch Rob's profile directly from the database instead of injecting it into the prompt. Once we have understanding how tools work, we'll take next steps into building our first AI agent that can actually perform tasks. That's it for this video. Make sure to subscribe to the channel Building SaaS and turn on the notifications so you don't miss the next episode. Thanks for watching, and I'll see you in the next one.